Welcome guys, in this video we are going to study the method of U-substitution for definite integrals. If you recall, in section 5.3 we were working with U-substitution for indefinite integrals. In this video we are going to study two methods of using U-substitution for definite integrals. So in the first method we are going to evaluate this integral using U-substitution, and then in our final step, when we get a function of u, we are going to substitute a function of x instead of u. And since our boundaries of integration here are set for values of x, and our resulting function will be a function of x, will be fine. All right, so let's jump straight forward to the method. Here, an apparent U-substitution is to use function u is equal to x squared plus 1, since derivative of it is equal to 2x dx, and we have this term x appearing here. Then we can replace x dx as du over 2. So this integral here is transformed into the following one. U cubed du over 2. Now we have to keep in mind that boundaries of integration right now are for values of x. So this integral is equal to u to the power of 4 over 8. And boundaries of integration are for x. So now we have to substitute a function of x instead of u, such that our boundaries will fit x squared plus 1 to the power of 4 over 8. Now, if we substitute 2, we'll get 5 to the power of 4 over 8, minus, if we substitute 0, we'll get 1 over 8. Okay, so our answer is as follows. So this is first method. And in second method, let's copy this integral again. Now, in our second method, we again will start by using U-substitution, but we also add a small additional step here. We are also going to change the boundaries of integration. In first method, we kept them in terms of x. Now here we are going to change them in terms of u, such that when we get to this step here, when we receive our integral as a function of u, our boundaries will be also in terms of u, so our boundaries will fit. Okay, so again, our U-substitution is u is equal to x squared plus 1. We also know that x dx is equal to du over 2. Also, when x is equal to 0, the value of u is equal to 0 plus 1, u is equal to 1. Then when x is equal to 2, if we substitute 2 instead of x squared plus 1 here, u is then equal to 5. All right, so now our integral is transformed into the following one. So right now boundaries are in terms of x. Now our boundaries will be transformed into boundaries in terms of u. So u, when x is equal to 0, u is equal to 1. When x is equal to 2, u is equal to 5. And our integrand is then equal to, again, u cubed over u cubed over 2 du. All right, now integrating will get u to the power of 4 over 8, and boundaries of integration are in terms of u. So we can then not use this step here. We don't have to substitute a function of x instead of u, since our boundaries of integration are also in terms of u. So what we'll get is then 5 to the power of 4 over 8 minus 1 over 8. Okay, so same result as we received in the first method. So these are the two methods for U-substitution when we are evaluating definite integrals. Let's evaluate the following definite integral using U-substitution. Here, if we use u is equal to 1 plus e to the power of x, then du is equal to e to the power of x dx, and we have this term appearing here, exactly what we need. When x is equal to 0, u is equal to 1 plus e to the power of 0. So u is equal to 2. When x is equal to ln of 3, then u is equal to 1 plus e to the power of ln of 3. So u is equal to 4. So our boundaries will change from x is equal to 0 from x is equal to 0 to x is equal to 3 to u is equal to 2 to u is equal to 4. And our integrand is then transformed into u to the power of 0.5, and e to the power of x dx is replaced with du. So our answer is then u to the power of 1.5 over 1.5. Boundaries of integration are from 2 to 4. So substituting these values, we'll get 4 to the power of 1.5 over 1.5 minus 2 to the power of 1.5 over 1.5.